The very first method, there are two methods for solving an integer problem. One is cutting plane algorithm, other is branch and bound. Now cutting plane algorithm, you can take a piece of paper and pen and use this method to solve it. Whereas the other methods require so many solutions, therefore it is not very feasible doing with pen and pencil, although you can do it but cumbersome. So purely from exam perspective, final exam perspective, where you have to write the solution, cutting plane is more important from exam perspective. Although from solutioning perspective, you need to understand both of them. So general idea is cutting plane, as I mentioned to you, this is the idea where we develop another constraint. Plane is nothing but an equation of a constraint, and constraint is developed in such a way that it helps in getting you the integer solution. So begin by solving LP relaxations of the LP problem. If the LP relaxation results in an integer solution, then you are done. Else I add a new constraint which cuts off the optimal solution. That's why it is called cutting plane. So cutting plane is basically like in the graphical solution earlier, you saw a feasibility region. So each cutting plane, as we will go, we'll put another constraint and will cut the feasibility region in such a way that we are moving towards integer value only. What constraint can be added, issue with this particular method, what constraint can be added such that no feasible integer solutions are cut off when the new constraint is added, but which are also eliminates the optimal solution of the relaxed problem from the feasible region. So let us understand it more by looking at the method. Now typically, in order to solve this method, generally the way it is done, you have a pure LP problem which is given at the top. Like if you forget for the time being x2 and x2 are integer, then this solution you can get with a simplex algorithm. And I am not going to repeat simplex part of it. Neither in exam you will be asked to do it generally. Sometimes if they ask you to do simplex and integer, it will be time consuming. So from that perspective, generally the way it happens is this problem is given to you, the way it is given, and final table is given to you here. And then using the final table, you have to develop a cutting plane and then solve it. So I'll repeat. Generally from solution point of view, what we do is we take a LP problem and get a LP solution first. Then we introduce cutting plane. But coming back to exam perspective, because that will be a cumbersome and long solution method, generally what is done normally is exam, this is given like this. This means problem is given, final solution of LP is given, and then you are asked to make integer solution. Is that clear?
Yes, sir.
So generally problem will be given and final LP table will be given. Now tell me, based on this table, what are the solution?
So maximum profit is 41.25.
Great.
X1 is 3.75 and X2 is 2.25.
Very good. All of you have understood what she has said? Guys, she has explained very nicely. Have you understood how to read this table? Because we have not given the variables on the left hand side, but you can still read it. Because variables, you have to look at the column and find and look at which is in 1, 0, 0 form. This means the bottom row corresponds to x1 row. So here has to be x1. Therefore, x1 becomes 3.75. That is what she has done. X2 corresponds to the second row, 2.25, and Z corresponds to the first row, 41.25. Perfect. Now with this, we'll go forward. So what you do is, listen carefully. You find here that both x1 and x2s are non-integer. Both are having decimal portion. So what we do is, we are going to develop a constraint, and from developing a constraint, we will choose a variable which has the largest decimal portion. This means we will choose a variable which has the largest decimal portion. So which is that variable here?
X1.
X1. Perfect. So X1 has the largest value of the decimal portion, 3.75. So then we'll choose this variable, and what we'll do is we go back to the X1 line. This means this line. So what is the equation of this line? Can you write this equation? How will write this equation? This we have to write X1 minus 1.25 S1 0.25 S2 is equal to 3.75. Is that right? I have just spoken the equation from X1 line. So
yes, sir.
So you have understood. So this is what we are saying. X1 minus 1.25 S1 plus 0.25 S2 equals 3.75. Having written this, now what you have to do is you have to segregate decimal portion and integer portion in such a way that decimal portion sign before decimal portion is positive. I'll repeat. You have to segregate decimal portion and integer portion in this equation in such a way that sign before the decimal portion is positive. This means, minus 1.25, we have to write 2S1 plus 0.75 S1. This we have to write minus 2S1 plus 0.75 S1. You got what I'm saying? Second rule
Yes,
is
sir.
Yes, sir.
segregate in such a way that this particular equation you segregate in such a way that the decimal portion of coefficient is always positive. So, but doing that, x1 is already integer, so x1, we break 0x2, you may write, may not write, minus 1.25 s1, that we break into minus 2 s1 plus 0.75 s1. Is this clear? Here 0 s2 you may not write, this will not do anything because you already have plus sign, equals 3 plus 0.75. Okay? So this transformation you have understood, x1 minus 2s1 plus 0.75 s1 plus 0.25 s2 equals 3 plus 0.75. Only thing I have done is I have segregated the decimal and integer portion. Is that clear?
Yes, sir.
Okay. So, yes, you need to tell me a little faster so that gives me confidence as well as I move forward. We'll repeat this process again, but let us complete one go. Now, what you have to do is you arrange all the integer and decimal one side. So, one side you bring all the integer, other side you bring all the decimal. So, this is just rearranging. By doing that, you get this particular thing. Once you do this, then this is the constraint. You write this constraint. From this equation, you see, left hand side, x1, s1, they are all integers basically, isn't it? They are all non-zero. So left and integer. So left hand side has to be an integer value. Now you can understand it a little differently. If you write the same equation here, let me copy this equation. And if I do like this means, if you just remove the minus sign from here, like I'm multiplying both sides with minus 1. The same above equation, I'm doing that manipulation. And this is minus itna, this becomes minus x1 plus s1 plus what I have written. This is okay.
Yes, sir.
This again I can write. I'm just showing all the steps. This again I can write like this. I'll move the decimal portion the other side. If I do this, I can just write here plus 0.75. Am I right? This 75 I remove from here. This okay? Here, this was plus here, no, minus. So this will be plus. This is okay?
Yes, sir. So why did we move it to the other side? We were keeping all the decimals in one side.
Just I'm trying to show you. I'm trying to establish an equation.
Okay.
What I'll do is I write this one as an inequality. That's why I'm doing all this jugglery. Because normally we know once we have inequality, then we know how to solve it. That to less than equal to condition. Now this arrangement is perfect.
Yes, sir.
So now what I can do is I can, and you see in the bracket, in the parenthesis, whatever written will be integer, will be some integer number.
Correct.
Okay. So here S1, S2 are greater than equal to 0. This means left hand side is either 0 or more. Is that right?
Yes.
So this means I can substitute this by a sign like this one. Equality co greater than equal to I can do. It was just equal to earlier. So I can write like this. And since this is integer, I can get rid of this also. Let me write like, let me not confuse you here. Let me write that stage again, this one here. So try understanding this step. This is critical because many times people have got, they ask questions here. What I'll do is, and I'll remove here this portion and I'll write here. Earlier I was saying greater than equal to. So instead of greater than equal to, since I require less than equal to sign, so what I'll do is, once you have this, then I write this again as a multiply both sides with minus 1 and then write the equation and change the sign greater than equal to, less than equal to. This is what, and this I'll make less than equal to, this I make minus Is it okay? Is it understood?
Yes, sir.
Now, if you agree with this, this becomes a new constraint. This is the new constraint. So what we'll do is we'll go ahead and we say, let's say equation 1 becomes a new constraint. So S1, S2 was already there. So in order to make them equal, I'll make it minus, this is 0.75, point has vanished somewhere. You know, like copying में point khatam ho gaya by mistake. So these all are 0.75. So don't say 75, this is 0.75. That is what is coming. So minus 0.75 S1. I'm just making them equal. So make equal at your end. Minus 0.25 S2 plus S3 equals minus 0.75. Is that right?
Yes.
So this is what we are going to write as a new constraint. So if you have understood this constraint, so what I'll do is I'll take the simplex table now, the final solution, and introduce one extra row at the bottom with this constraint. Extra row, S3 row I have introduced, and extra column you have to introduce because S3 row I have introduced here. So this table is nothing but this portion up to this portion, like first 4 arrows, first 4 rows. These are the table which was given you in the problem. So what you have done is the problem was given, this highlighted one was given to you. We just developed a new constraint equation and added in the table. That's all we have done. So this part is understood, Natasha?
Yes, sir. Got it.
Naveen? Boys are keeping mum, girls are only speaking.
Yes, sir.
Okay. Now tell me, now you know how to solve it. This is all is cutting plane method. Just developing a cutting plane is required. So tell me, is this table optimal?
No, sir.
Maximization Z row. Naveen, is
Yes,
this
sir.
optimal? Is this table optimal, which is in front of your eyes?
No, sir.
Yes, sir. It is optimal.
So the
It
Z
is
row is
optimal. No, let us ask no first so that he gets clarified. Why you have said no? Because it's maximization problem. And Z row has to be 0 or more. So that is what you see here. All the Z entries are 0 or more.
I thought that I considered the last row at Z. I'm so sorry, sir.
No, no,
I-
anyway.
I-
So it is optimal. Is it feasible?
Yes, sir. It's feasible.
Why alternatively you guys commit mistake? I am
Okay,
little
yeah,
scared.
yes, sir. It's not feasible because we have the negative sign in S3.
Absolutely. So it is infeasible but optimal.
Yeah,
So let us
right.
look at here. It is optimal because all entries in Z rows are positive, 0 or positive. It is not feasible because one of the entry in the right hand side is negative. So which method we have to apply to make it to take it further? Between simplex and dual simplex, which method we have to apply to take it further?
So dual simplex.
Absolutely right. So which is the outgoing row? S3 is the outgoing, and we will take the ratio of Z row, you know, like what do you call, in this particular non-basic variables and this row and the corresponding ratios. So from that perspective, what are the ratios we have to take?
So 1.25 by 0.75 and 0.75 by 0.25.
Come again.
So 1.25 by 0.75 we take
Okay.
because we consider the mod, so we are not considering the negative sign,
Huh.
and 0.75 by 0.25.
So which one is lower? Obviously S1, isn't it?
Yes, sir.
So from that perspective, S3 is replaced by S1. So in next solution, this is what will happen. So once you do the operation, this will look like this. So now you have a new table after doing the row operations where you have made S1 came into the solution. You made all the entry in S1 column 0 except the pivot element, which is intersection of S1 row and S1 column. So after doing this, you get a new solution. Now tell me, is it optimal?
Yes, sir.
Is it feasible?
Yes, sir. It's feasible.
Third criteria now, are the solutions integer?
Sir, it's a mixed solution, integer as well as binary.
Bind is also a special case of integer, no?
Yeah, right. So, sir,
So
yes.
we have achieved the goal. So finally we have got a solution which is optimal, which is feasible, and also which has got integer value as per our requirement. So whatever requirement we have, so this method is known as cutting plane method, and I hope you have understood the cutting plane method. So let me go and check up with people if they have understood the cutting plane